Hello students, welcome to my channel Bhavyaphysics. Today we are going to discuss 2 marks questions of Model Question Paper 3 of the year 24-25. Before answering these questions, if you are new to my channel, please subscribe my channel and press bell icon to get the notification of new videos. If you are already subscribed and if these questions are helpful, please like my videos and share to your friends. If you have any confusion or any opinion, please comment in the comment section. Now the questions are like this. Name the two factors on which resistance of metallic wire depends. So it depends on resistance of the wire depends on length of the conductor, directly proportional to length of the conductor, inversely proportional to area of the conductor, and directly proportional to temperature of the conductor. And resistance also depends on material, nature of material of the conductor. So we know that this current carrying wire is cylindrical in shape. So resistance is opposition offered by this wire for the flow of current. When electrons are moving from one region to another region, so this wire must be connected to the potential difference or battery. Okay, then electron starts moving from this end to this end, right? So it starts to move like this. Electrons are drifting. As electrons are drifting, there is a chances of colliding with other electrons, or these electrons may collide with immobile ions. So these collision, because of this collision, this movement slows down, right? Or this is called as opposition or resistance. So resistance depends on number of collision. More the number of collision, more resistance that wire offers. So if the length increases, what happens? If the length of the wire increases, this collision rate also increases. Number of collision increases. Therefore, resistance is directly proportional to length. Is this clear, student? So number of collision is nothing but resistance. If the more the collision, this electrons movement slows down. That's why if the number of collision increases, resistance increases. That means if you increase the length of the wire, then resistance increases. And area. So area, if I take this is a metallic wire which is cylindrical in shape. Now if area increases, area is nothing but thickness. See, if the thickness increases, then what happens? If the thickness increases, say number of collision decreases, because this electrons finds more space for its movement, right, without collision, right? So therefore, if the thickness of the wire increases, collision rate decreases or resistance decreases. Therefore, as area increases, resistance decreases. So they are inversely proportional. And third point is temperature. So temperature is nothing but thermal energy here. So when you heat this metallic wire, each electron absorbs energy and its temperature increases, right? So when the thermal energy increases or internal energy increases, then movement of the electron increases. So electron starts, kinetic energy increases, right? So that's why electrons are moving randomly here and there. So movement increases, that implies number of collision increases. Collision rate increases means resistance increases, right? So therefore resistance is directly proportional to temperature, and it depends on nature of the material of the conductor. So nature of the material means different material is having different number of electrons, right? So therefore resistance depends on nature of the wire, material of the conductor. So these are the factors on which resistance depends. So you have to write any 2 points. Okay. Yes, next question is, when does current carrying conductor placed in uniform magnetic field experiences maximum force and minimum force? So for this, first thing you should remember the formula of magnetic force experienced by current carrying conductor. So that is F is equal to BIL sin theta. It is easy to remember. See, one thing is it depends on magnetic field. Okay, another one is length of the conductor, another one is a current which is flowing through the conductor, right? One is length of the conductor, another one is current, and where it is placed, it is placed in magnetic field. So, and another one is angle theta between length and magnetic field. If I consider the coordinate axis like this, okay, and this will be the direction of magnetic field, okay, and if the wire is placed like this along the direction of the magnetic field, then if the wire is parallel to magnetic field and current is also flowing along this direction, so theta is 0, theta is angle between length and magnetic field which is 0, then sine 0 is 0 degree. So if sine 0 is 0, force will be 0, then it experiences minimum force, right? Force is 0. Suppose if magnetic, let us consider, see here, this is a direction of magnetic field, okay, and the conductor is placed like this, okay, this is a conductor, current carrying wire, such that the angle between them is 90 degree, okay, angle is a, theta is angle between length as well as magnetic field, okay, so angle is 90 degree, then sine 90 is 1. So it experiences maximum force, right? Maximum force is how much? BIL. The next question is, define magnetization of a sample, how it is related to magnetic intensity. So magnetization is nothing but magnetic moment acquired per unit volume of material when it is placed in magnetizing field. Okay, so the field which magnetizes the material is called as magnetizing field. That is a source. Okay, that field is called as source which magnetizes the material. And the material which gets certain magnetization, right? So the magnetization is nothing but the magnetic moment acquired per unit volume of a material. Okay, when it is placed in magnetizing field. So therefore, the relation is Im, or you can also write small m, is equal to capital M by moment per unit volume is called as magnetization. And this magnetization is directly proportional to intensity of magnetizing field. Intensity of magnetizing field. So therefore, if I remove this proportionality, there is one constant called as susceptibility, magnetic susceptibility chi. The next question is, a boy pedals a stationary bicycle. The pedals of the bicycle are attached to a coil of 100 turns. Each turn of area is given 0.2 meters square. The coil rotates at 6 rotations per second and it is placed in uniform magnetic field of 0.01 Tesla perpendicular to the axis of rotation. Calculate maximum value of EMF generated in the coil. This question is from EMI chapter, electromagnetic induction. EMF generated can be written as B magnetic field, area, okay, number of turns in the coil, and omega, that is angular velocity or angular frequency, and sine theta. See here it is given that the coil which is placed perpendicular to the axis of rotation of the coil. So the uniform magnetic field is perpendicular to the axis of rotation. Okay, how the coil is placed, it is perpendicular to the magnetic field. Therefore theta is 90 degree. Theta is 90 degree means it is maximum EMF. Electromagnetic force is maximum, so which is written as E naught. E naught can be written as BAN omega. Everything is given, so you just remember this formula, BAN omega, or any, see, NAB omega, like that. So when theta is 90 degree, the EMF generated is maximum. Okay, so substitute the number data given as it is, everything is given here. Okay, so number of turns is given, so which is 100, and area is 0.2. Okay, and we can write omega as 2 pi f, 2 pi, and f is 6 rotation per second, and magnetic field is given. Substituting will get this number, 7.536 volt. Please note down. Next, what is displacement current? This is AC chapter. Give the expression for it. So remember this formula always. It's very important question for 2 marks. Displacement current is nothing but it is a current, electric current produced due to varying electric field. Inside the capacitor, due to electric field, when electric field varies, when there is a change in electric field in between two capacitor, okay, when there is a change in electric field, then there is a displacement current. Displacement current is produced due to varying electric field. So this displacement current can be written as epsilon naught d phi by dt, okay, d phi by dt. So where what is d phi? D phi is change in the electric flux in time dt. Next question is, mention two uses of Polaroids. It's from wave optics chapter. Polaroids are used in sunglasses. Polaroid sheets are used in window panes of trains and aeroplanes. Polaroids are used in three-dimensional movie cameras. Polaroids are used for viewing three-dimensional pictures. Students, you should write any 2 points if it is asked for 2 marks or 3 points if it is asked for 3 marks. So 4 points are given here. So note down all the 4 points and please remember at least 2 points or 3 points for writing in 2 marks and 3 marks. Write 2 limitations of Bohr's atom model. So here also there are 4 points. You try to remember at least 3 points so that if this question is asked for 3 marks, you will be in a position of writing 3 points. Here this is asked for 2 marks, so that's why just remember 2 points. Write 2 points. It is not applicable to atoms having more than 1 electron. So because Bohr atom model is applicable to hydrogen and hydrogen-like atoms, so if there are more than 1 electron, Bohr's model could not explain, okay, so it is not applicable to atoms having more than 1 electron, and it could not explain the fine structure of spectral lines, and it does not account for the wave nature of electrons. It cannot give any information about intensity of spectral lines. The last question from this model paper, 2 marks questions, is how can a semiconductor diode be forward biased? What happens to the width of depletion region when forward bias voltage is increased? See, here in semiconductor diodes, we are having PN junction, right? So this PN junction means it is a P-type. P-type is having majority of hole and N-types are having majority of electrons, okay? So when P-type is connected to the positive terminal and N-type is connected to negative terminal, then it is said to be forward biased, okay? And this is called as junction, which consists of immobile carriers, negative and positive carriers. So when it is connected to the battery, and when, see, in forward biasing, polarity of junction potential is opposite to the applied voltage. So here you are observing that this side there is a negative immobile ions and this side there is a positive immobile ions. Because of this, there is a electric field or junction potential which is in opposite to the applied voltage, okay? So applied voltage is acting, say this is positive and here it is negative, whereas here this is negative and this is positive. So it is reverse, okay? It is opposite to the junction potential is opposite to the applied voltage, and when forward bias voltage is increased, this width of the depletion region decreases because the positive, see here what happens, when you connect this junction, when you connect this applied voltage, positive charges are repelled by this, that is holes are repelled, and hence it starts to move like this. When holes starts to move or electrons are moving in this way because electrons are attracted by positive, as it starts to move, what happens, this depletion region decreases, because depletion region is nothing but depleted of mobile charges or mobile carriers, okay? So if it is depleted of mobile carriers, then it is called as depletion region. Depleted means, I hope you know the meaning, okay? So it is less number of mobile carriers. But once if you connect this battery, and as you increase the battery voltage, then what happens, these holes are repelled and hence it starts to move through this depletion region, or electrons are attracted by this and hence it starts to move like this. When it starts to move, this depletion region width decreases. I hope it is clear. Students, like this, 2 marks questions. I have answered all model papers, 3 model paper of 24-25 2 marks questions, and it is easy to answer. So sometimes they may ask write 2 factors on which something is depends, or some limitations, 2 limitations, or state and explain, or when this is maximum or minimum, or define something, or you should write the expression and explain the symbols using, or you may write certain some formula substitute and write the answer, that type of problems, or mention the expressions, okay, or users. This type of problem you can expect in 2 marks, and try to answer all the 5 questions out of 8 questions. You need to answer 5 questions to get 10 marks. Okay, so please go through these 2 marks questions. I answered all 3 model papers. Go through these 3 model papers solutions. Okay, and I hope it will be helpful to you for coming exam in the year 25. So if you have any opinion, so you can comment below in the comment section, or if you want me to solve any of the paper, you suggest me, so that in next video I'll upload that. Okay, thanks for watching.